Let's jump into some parametric equations. Our parametric equations are something that you're going to see a little bit of if you're going to physics. So let's get comfortable with this concept before you get into physics, because you know what, physics can be a little uncomfortable, and I'm hoping you can make it into the class and you're worrying more about the physics rather than the math. You're also going to see this in Calculus 2, Calc 3, if you'd be going there. So there's reasons, not just to make your life tough. Let's go. And here's the game. Here it is. This is it. Right there. We're going to say x is equal to a function. You're like, what? Yep. X is equal to a function. I'm going to misspeak, of time. And y is equal to a function of time, but a different one. Okay, well, thanks for all that notation. What's that mean? Well, let's look. I got this little random graph. No, it's just a graph. Look, I got a y-axis. Got an x-axis. Cool. And when we graph something, typically it's static. It's just sitting there, right? There's no direction or anything. So I'd like to think about this. That what if x values were determined by time and y values are determined by time? Because we're looking at 2 dimensions right now, correct? Well, I can add a 3rd dimension to this. Watch. I'm going to get rid of the graph. Now watch. Watch me add it. Here it comes. Here's the 3rd dimension. Did you catch it? Did you catch the 3rd dimension? You can see 2, but what's the 3rd? It was time elapsing. There's direction to this curve. So unlike a graph you would typically see in an algebra class, when we're talking about a parametric equation, it has what's called orientation. The fact that I put some arrows on this and told you what direction it's moving, we've now created something more dynamic, something that we can see over a period of time. So while these parametric equations, when we use this value t, does not necessarily mean time, it's kind of nice to think about it as if it's time passing by. Okay. Now that we had so much fun there, let's jump into the definitions. And I got to do it, right? We got to talk for a second. So if we say, if f and g are continuous functions on t on an interval I, just calm down, just let that shit go. Just let it go. Then the set of ordered pairs, f of t, g of t, now stop, just go. X comma y. We're just defining x and y, really freaking weird. And we call it a plane curve. Okay, just the term. It's a plane curve. Don't worry about the c, don't worry about the t, the interval I, all that crap yet. Just whatever. Where we're saying x is a function of time and y is some other function of time. Oops, I should just be saying a function of t because it doesn't have to be time. Now here's the big one. So it's called parametric equations, but let's make sure we have this. T is called the parameter, hence a parametric equation. Where we're saying we're adding this like 3rd variable. I'm using big quotes right now. So there's not just an x and a y, there's also a t that for ease of use we think of maybe as time. Okay, it's a lot. So let's just jump into it. Let's kind of see what's going on here. Let's go look at this. Is like a question I could ask you. We want to graph a curve defined by the parametric equations. And here's the 2 parametric equations. X is equal to 4t squared and y is equal to 2t. And then off on the right, it just tells us what values of t's to start on. And I wrote just 2 and 2. This needs to be -2 up to 2. My bad. So that's saying 2 seconds ago up to 2 seconds in the future. 2 hours in the past up till 2 hours in the future. I don't know. I like thinking of it as time. So let's graph it. And you're going to find that it's actually not that bad to graph it. There's 2 different ways. I'm going to show you the first. Make a table. Just make a table. Look, we have it. We have that x is equal to 4t squared. So what I've done is I set up a table. It says that, well, the t values go from -2 to 2. So it's like, well, let's plug in -2, -1, 0, 1, 2 into like our x's and our y's. And let's figure out what they are. So let's start. All right. So -2, let's pop it in. And we're plugging that in for t, all right? So we're going to say that our x value is equal to 4 times -2 squared. Sorry about my dog. He hears me talking. He likes to come in. So our x value here, we go x is equal to 4 times. What's -2 squared? What's -2 squared? Oops. What's -2 squared? Isn't that 4? And what's 4 times 4? Isn't that 16? Cool. And we're going to go through and do this. We'll find all of our values. Now I'm going to plug in -1, right? We'll square -1. I'm just going down. So we get -1 squared is equal to 1, and 1 times 4 is equal to 4. So we put that in. Cool. There we go. So that was for -1. Now let's pop in 0. And it's tedious. It's tedious, but it's no big deal. What's 4 times 0? Isn't that 0? And if we continue along and plug all these values in, because we're squaring this, this is the same as -2 and 2. And 1 is going to get you the same answers. Hence, when we plug it in, we're just going to get a 4 and a 16. Okay. So you're going to get the same answers because we're squaring it, right? We're squaring it. Well, now we're going to play the same game with y. For some reason, my stuff is kind of corrupted. I don't know why. So now we can plug in t is equal to -2. And we're like, well, what's y? Y is equal to 2 times -2. So that's equal to -4. So we just pop it into there, and we just go down the same way. Just keep plugging these numbers in. Plugging them in. Till you get it. And yeah, it's tedious, but I'm going to show you another way that's a little bit simpler. Right? 2 times, y is equal to 2 times, y is equal to 2 times, and then we just pop those numbers in. We're just filling out a table. Just filling out a table. And so this is -2, this one would be 0, this one would be 2, and that would be 4. So we just pop them in. And what this allowed us to do is we now have ordered pairs. We can do an x, y. Y'all know how to plot points. That's what we're trying to get to. So then we just put it in, and I'm just going to write it in one color. We're just going to call that 16, -4, 4, -2. We got the origin. We got 4, 2, and we got 16, 4. All right. Well, let's graph it. Fortunately, I already got a graph already kind of hanging out right down here. So let's see what we got. Got our table up here. Let's move this down a little bit. Let's move this down so where we can see it. Okay. So let's graph it up. So let's look at our first point. We got 16, -4. So I'm going to graph it in green because why not? So it's like 16, -4. What? Call it there? Is that okay? 16, -4. Close enough, right? Then we're going to go down to 4, -2. Like 4, -2. Let's just get it close enough. What about there? 4, -2. We got our origin coming up next. Right, so right through the origin. Our next is +4, +2. So, I think we're just right up here. 4, 2. And then our last one is going to be that 16, 4. Oh, so right about here. So this looks like, now sorry, my drawing is going to be probably pretty terrible here. I'll do my best. Hey, that's not so bad. It looks kind of like a parabola on its side. But when we graph these things, we have to give it what's called orientation. We need to go this way. You know what I mean? Through time, as we went. So we look at our first point, that's where we're going to start. We started here, so we make little arrows, and this is our orientation, telling us which direction we go, because when we do parametric equations, it moves in an order, just like time would. So we've graphed that sucker up. We have it. Yeah, there we go. There we go. We graphed it. Cool. Now that's the long, tedious way of solving one of these. The quick way is to, well, we can eliminate the parameter. So hang on, we're almost there. I'm not going to go any more graphing. We're just going to take our original from back here and just show a different method. We have two things. X is equal to 4t squared and y is equal to 2t. Let's bring this over. That x is equal to 4t squared and y is equal to 2t. Now watch this quick game we could do. This is called eliminating the parameter. And we'll do a lot more of this. The game is, hey, maybe solve for t. Maybe let's get t all by itself. So we'll divide out the 2. We divide out the 2. And we're like, wait a second. T is equal to y over 2. And pop it back into the other equation. The other parametric equation. So we're like, okay, well, x from right up here. X is equal to 4 times t squared. But t is equal to y over 2. So what do we have here? X is equal to 4 times y squared over 4. They just cancel out, and it appears that we have x is equal to y squared. Oh shoot, that's just a parabola on its side. The only thing we missed is we just don't know where we're allowed to draw, because look what I drew. I drew an actual parabola on its side. But look at these arrows I put in. It doesn't go on forever. We graphed it before. It only goes to 16, 4 and 16, negative 4. It doesn't go any further than that. So eliminating the parameter will get you the shape really quick, but we won't know how far to graph. So this was a ton of material I just gave you right off the bat. We're going to go through and do some simpler examples as we go. But yeah, this is the basic game. Parametric equations. And then we're going to do my favorite frickin' word problems at the end. I love these, and you're going to need to do them in your physics classes and in your calc classes. So it'll be good practice. But hang in there. We got more. See you.